Hello and welcome. In this tutorial, I'm going to show you how to create Flappy Bird in Godot. Let's take a look at what the final game is going to look like. As you can see, it is the classic Flappy Bird game. If you are very young, you might not even remember what this is, but this used to be a very popular and rage-inducing game back in my days. And this is how it goes. There's a bird, it flaps, there's obstacles, and it's a very good project for beginners to do. It's relatively easy to create, but there is some tricky parts which I'm going to explain in detail. In order to go through this tutorial with relative sanity, you should know the basics of Godot, things like scenes, nodes, signals, and also scripting with the GD script language. If you don't know those things, you can take a look at my completely free beginner mini course or tutorial. There's a link for that in the description. It's inside my free community for Godot developers. You can also find the assets for this tutorial inside of that community as well. So take a look at that. And if you want to learn Godot seriously, if you want to learn everything there's about Godot, master it, you can take a look at Godot Academy, which is my course/mentorship for people who want to make games with Godot. This tutorial is divided into lectures. You can find a list of them in the description, and that way you can navigate the different parts of the tutorial. With that being said, let's go ahead and get started. Okay, so let's open up Godot and create a new project that we're going to call Flappy Bird. We're going to pick a location for this that we like. For me, that is going to be right here. Then we can go ahead and create it. First of all, I'm going to create the main scene that the game is going to take place in. This is going to be a 2D scene with a node 2D at the root, and we're going to rename this to be the game. Just like that. We're going to save this in a folder called scenes. In the file system, we'll right click here, create a new folder called scenes, and all of our scenes are going to be inside of this folder. Now we can go ahead and hit the Ctrl S shortcut to save the game scene into this folder, just like that. Then we're going to set this scene as the main scene. The main scene is the scene that is run first when the game starts. We can do this by clicking the Run Project button, and then we can click on Select Current. That way, when we play the game scene is the scene that gets run. We're also going to create a folder for the scripts that we're going to create, just like that, and also a folder for the assets that we're going to import in just a second. Let's do that actually. Let's import the assets. If you take a look at the description, you will see a link where you can get these. If you want to use the same assets, you're going to download the zip folder, you're going to unzip it, and in that folder, you're going to find these folders. You can select all of them and drag them onto the assets folder to import them into Godot. You can see that we have some sound files here that we're going to use. We have a font that we're going to use for the text, and we also have some textures that we're going to use. Great. If you take a look at the window when we play the game, you will see that it is very wide, like a traditional game window. In the case of Flappy Bird, we want to have a much more narrow window that is going to be taller, much more like a mobile device. We're going to fix that in the project settings, and we're also going to fix the way we render these textures. At the moment, if you bring in these sprites into the game, you will see that they look very blurry. They look blurry because these are pixel art assets, and by default, the texture filter is not set to render pixel art properly. You can actually go into the texture settings of the sprite. There's an option here called filter, and this is set to be linear by default, which is fine for regular sprites, but for pixel art, we want this to be nearest. You can see that when we pick nearest, the pixel art is displayed nice and crisp and properly. We don't want to do this each time we create a sprite 2D. That is why we're going to also change this setting from the project settings as well. So let's go there into the project settings. First of all, we'll go down to the textures section here. Make sure to have the advanced settings option on, which is going to give you a ton more options to see. In here, we're going to set the default texture filter to be nearest instead of linear, which is going to mean each time we bring in a pixel art asset, it's going to be displayed properly with the nearest filter, as you can see. We can also play the game to see them as well, and as you can see, they look nice and crisp. Next up, we'll go into the window section. In here, we can set the window size, the width and the height here. We're going to set this equal to the size of the background image. If you double click on it, you can see here that it is 480 by 854. We're going to use the same resolution. So we'll set the width to be 480 and the height to be 854, just like that. We're also going to go down and set the stretch mode to be canvas items, so that when we resize the window, everything is scaled up properly. Now, as you can see, the viewport rectangle is much more like a mobile device. And when we play the game, it is going to look like this. Awesome, now we can get rid of all of these sprites. We can just delete all of them. And next up, we're going to create the background image or the background sprite using the background.png texture right here. And I'm going to give that to you as a challenge. So this is the first challenge of the tutorial. The way these work is very simple. You're simply going to pause the video, take a look at the instructions that I'm going to give you, and try to do this yourself. After you're done, you can come back to the video and continue watching. So first of all, I want you to create a Sprite 2D node inside of the game scene. You're going to rename this to background. After that, I want you to assign the background.png texture to the texture slot of the Sprite 2D. And finally, I want you to position it so that it covers all of the viewports. Pause the video, give this challenge a go, and come back when you're done. Alright, we're going to click on the root node, create a new node, which is going to be a Sprite 2D. You can do it this way, or you can simply drag the background image into the viewport as well, which is going to create the Sprite 2D automatically. It's also going to name it automatically based on the name of the texture, and it's also going to assign the texture automatically as well. This is kind of like a shortcut, but I'm also going to show you how to do it the long way. So let's create the Sprite 2D manually. Let's rename it to be background. Then we're going to assign the background.png to the texture slot, just like that. And finally, we can position it like that as well, so that it covers the viewport exactly. Let's see what the position is for that. It's 240 for the X and 427 for the Y. That is one way to position it. We could also reset this to be 0, 0, go into the offset section here and turn off this centered, which is going to place the center of the Sprite 2D to the top left. And that is going to essentially automatically position it over the viewport. Just like that, both ways are fine. I'm just going to keep it like this. And finally, while I have this sprite selected, I'm going to lock it using this button so that we don't accidentally click on it in the viewport and reposition it. Okay, so next up, we're going to start creating the player, which is going to be a new scene. Let me explain how the player is going to work. First of all, the player is going to be a bird that is going to be flying in the air. Each time the player presses the left mouse button, it's going to flap, so it's going to go slightly upwards, and it's also going to fall down due to gravity. While it's falling down, we want it to rotate downwards like that, and while we flap, or when we flap, we want it to rotate upwards slightly, just like that. In order to implement something like this relatively easily, we can use the rigid body 2D node in Godot. This is a node that is going to use the built-in physics system. So in order to make it go upwards, we can simply set the linear velocity. And in order to make it rotate like this, we can use the angular velocity. And the rest is going to be taken care of by the physics system. And also a fun fact, in this game, we're actually not going to make the player move forwards. The player is always going to stay in one place, and the obstacles are going to move towards the player, which is going to make it easier to actually implement the game. So let's start here by creating a rigid body 2D as the root node. We're going to rename this to be the player, save it into the scenes folder. We're also going to create a script here. And this one is going to be inside of the scripts folder. Just like that. Inside of the scene, we're going to create a Sprite 2D. to display the player's graphics, a collision shape for the rigid body, and also an animation player, so that we can create the animations of the player bird. For the sprite 2D, we're going to use this bird.png sprite sheet. A sprite sheet is a texture with multiple frames of an animation inside of it. In this case, there's a single animation and there is 3 frames. In order to set this up, we need to go to the animation section here in the sprite and set the horizontal frames to the number of horizontal frames we have, in this case 3. Vertically, we only have a single frame, so we don't need to change this one. After we set this up, we can use the frame property here to go through the different frames of the animation. In this case, we have 3, as you can see. And the first one is at index 0, the second one is 1, and then the third one is 2. So it starts at 0 instead of 1. Keep that in mind. We're going to use this frame property in order to create the animations of the player. The player is going to have 2 different animations. The first one is the idle animation that we're going to start at the start of the game, before the player begins flapping its wings. And the second one is going to be the flap animation, and that one we're going to use each time the player flaps. So let's go ahead and create the idle animation first of all. This is going to be autoplay, so that it starts playing immediately when we start the game, and it's also going to loop. We're going to make it 0.8 seconds long in total. Let's zoom in a little bit. I'm going to turn on snap here so that the cursor snaps, and also going to set the snap to be 0.1 so that we snap to each 0.1 increment. This is just going to make it easier to create the animation. In this animation, first of all, we want the player to go up and down slightly, which is going to look cool. And we also want the player to flap its wings 2 times throughout the animation. So let's start with that part. We can click on the sprite 2D and key the frame property to achieve that. The first one that we're going to key is going to be frame 1, which is the second frame. Then we're going to move the cursor to 0.1, and then we're going to key frame 2 right here. Then we're going to key frame 1 again at 0.2, and then finally at 0.3, we're going to key frame 0 like that. So that's going to be one cycle of flapping wings. We start in the middle, we go up, middle again, and we go down. This in total is going to take 0.4 seconds. We're going to do this one more time, and that is why the entire animation is 0.8. It's 2 flap sequences long. What we can do here is we can hold down the shift key, click on all of these keys, right click, copy these keys, put the cursor at 0.4, right click here and paste the keys. And that's going to be it. Now we should be able to play the animation. And as you can see, the bird is going to flap its wings continuously. Next up, we're going to make it go up and down. And to do that, we can key the position of the sprite 2D. So we'll go into transform. At the start of the animation, we're going to set the Y position to be -5 so that it starts at the top. We'll key this. And in the middle of the animation, we'll set this to be +5, which is going to be the bottommost position of the sprite 2D. And we'll key that. We don't need to key anything else because towards the end of the animation, it's going to go upwards to the starting value, which means we can play this animation and it's going to go up and down continuously. We can make this look even nicer by clicking on this option right here for the position and set it to be cubic, which is going to create a smoother interpolation, as you can see. Great, so that is the idle animation. Next up, we're going to create the flap animation. For this one, first of all, we want to key the position of the sprite 2D to be 0, 0, because the idle is going to mess that up. So at the start of this, we're going to key 0, 0 for the position. And after that, we're going to create a flapping animation again using the frame property right here. We can start in frame 2, key that, then we can go to the middle, then downwards, and to the middle again. And this is going to be 0.4 seconds long. And we're keying these at 0.1 increments, as you can see. So that's going to be the flapping animation. All right, next up, let's create the collision shape for the rigid body 2D, which is going to be a circle about that size. Should be fine. And now we can go into the game scene and instance the player here so that we can see what the animation looks like. We're only going to be able to see the idle animation at this moment. So let's play the game, and the player is going to fall down immediately, as you can see. Which is actually not what we want. We want the player to hang in the air and play the idle animation going up and down until we start playing. So we need to disable the player's gravity at the start, and that is going to be your challenge. Go ahead and turn off player's gravity so that it doesn't immediately fall down at the start of the game. We're going to do this from the rigid body 2D node inside of the player scene. Pause the video, give it a go, and come back when you're done. Alright, let's go into the player scene. Click on the rigid body 2D node. And here we have the gravity scale property. By default, it's set to be 1. We're going to set this to be 0 to essentially disable the gravity. And now the player is going to hang out in the air and play the idle animation. And later on, when we first flap by clicking the left mouse button, we're going to set the gravity scale back to be 1, and we're going to essentially start the game. But for now, this is what the player is going to look like. Okay, so next up, we're going to implement the falling mechanism of the player, and we're also going to create the skeleton of the flapping code or the movement code of the player at the same time. Basically, at the start of the game, before the player starts flapping, the player is going to hang in the air just like that because the gravity scale is set to 0. When the player presses the left mouse button for the first time, we're going to set the gravity scale back to 1. This is going to make it so that the player starts falling because the game has just started. And while the player is falling, we're going to make it rotate downwards for a total of 90 degrees so that it looks down as it goes down. The first step of this process is going to be detecting the input. In order to do that, we need to create an input action inside of project settings, input map, right here. And creating that input action is going to be your challenge. Go ahead and create the flap input action, that is the name. And I want you to bind the left mouse button to this input action. You can also use a different key or a button if you like, but I'm going to use this one. Pause the video, give this a go, and come back when you're done. Alright, we're going to type in the name here, which is flap, create it, and then we're going to bind the left mouse button, which is right here. Next up, we'll go into the player script. We're going to check for this input in the physics process function. The physics process function is called every frame, which is going to be great for checking for input, and it's also the proper function to use when you're doing something with the physics engine. We're going to create an if statement here, and we're going to use the input is action just pressed function. This is going to take in the name of the input action as a string, which is flap, and it's going to return true if this is pressed and false if this is not pressed. And it's only going to return true the first time we press it. To see this working, we can print something here. Something like flap is pressed. I'm also going to put an underscore here to get rid of that warning. We're going to play the game. And when we press the left mouse button, the if statement is going to be executed, as you can see. And it's only executed once. Even if I hold it down, it doesn't get executed more, only that first frame, which is exactly what we want. We want to flap once when we press the left mouse button. We don't want to flap over and over again. So right here in this if statement, we need to create this type of logic. First of all, we want to have a function called flap that is going to make the player go upwards. We also need to have a function called start game, which is going to be called only once the first time we press this input. And the start game is going to do things like setting the gravity scale back to 1 and other setup that we might do in the future. In order to create this structure, we're going to create a Boolean variable up here called started, which is going to be false at the start. Then we're going to create those functions, start game, and also flap. Just like that, both of these functions are not going to accept any arguments, and they're both going to return void. We're going to call flap when the input action is pressed. We're also going to call start game when this input action is pressed, but we only want to do this once. That is why we created this Boolean. So first of all, we're going to check if the started Boolean is false. And we can do it like that using the not operator. If it is false, that means the game hasn't started yet, so we'll call start game. And then we're going to call flap in any case. Inside of the start game function, we're going to set the started Boolean to true so that the next time we press the flap input action, we don't call this function again. Then we're going to set the gravity scale to 1, but first of all, let's print some messages here to see if this structure is working or not. We can say start the game here. And in the flap function, we can say flap is pressed. If this works, when we first press the left mouse button, we should get both of those messages, like that. And then we should only get flap is pressed as I continue pressing, as you can see. Perfect, that is what we want. Now we can set the gravity scale here back to 1. And we know this is only going to be run once. With this, I should be able to hit the left mouse button. That is going to activate gravity. And after that, it's not going to be called again. Perfect. But you can see that the player is not rotating while it goes down. And also, the player is still inside of the idle animation after we start the game. So we need to change those things. First of all, inside of the flap, we're going to play the flap animation. To do that, I'm going to create a reference for the animation player. We can simply drag this into the script with the left mouse button, hold down the control key, release the left mouse button, and that's going to create an onReady reference for the animation player, which is a neat shortcut. And then we can use this reference inside of the flap function down here. We can access the play function, and we're going to give this the animation name that we want to play, and that is called flap. This way, when we call the flap function, we're going to switch into the flap animation, as you can see. At the moment, it is not that noticeable, but as we implement flapping, this is going to become obvious. Let's also make the bird rotate downwards as well. We're going to do that in the physics process because we want to do this over and over again in each frame. We only want to do this while the player is going down. To check for that, we can take a look at the linear velocity and specifically the y velocity, which is the vertical velocity of the player. Let's take a look at this by printing it out. You will see that at the start it is 0, and when we enable gravity, it becomes positive, which means while this is a positive number, we are falling down. So we can create an if statement that checks for that. If the linear velocity is greater than 0, this means the player is falling down. If that is the case, let's go ahead and rotate it. And to make it rotate, we can set the angular velocity, which is another built-in variable of the rigid body 2D. We can set this to something like 5, and that is going to make it rotate, as you can see. But at the moment, it is rotating more than 90 degrees. We want this to stop after it rotates for 90 degrees, which is going to be another if statement. We can check the degrees of rotation with the rotation degrees built-in variable. If this is greater than or equal to 90, or we can actually say less than or equal to 90, we haven't rotated all the way yet, so let's go ahead and set the velocity to be 5. Else, we have rotated 90 degrees. In that case, we're going to set the angular velocity to 0. Now when we play, the player is going to stop rotating after it reaches 90 degrees of rotation, as you can see. And this is going to be the start or the beginnings of the player's movement code. We created this structure in order to check for player input with the left mouse button. If this is the first time we're doing it, we're calling this start game function. And in here, we're enabling the gravity so that the player falls. We also created the flap function, which is always going to be called whenever we press the flap input action. In here at the moment, we're only playing the animation, but later on, we're going to make the player go up. And of course, we created this piece of code right here in order to make the player rotate downwards as it falls down. So continuing with the player, we're going to implement the flapping logic. This is going to have two parts. First of all, we want the player to go upwards vertically when we press the left mouse button. And at the same time, we want the player to rotate counterclockwise like that. And we want to limit this to something like that so that the player doesn't do a full circle. In this game, as I told you previously, we're not going to make the player move horizontally, so we don't need to do anything about that. Instead of doing it that way, later on we're going to spawn obstacles, the pipes, and then we're going to make the obstacles go towards the player, which is going to create the illusion that the player is moving, but in fact it is not moving, the obstacles are moving, which is kind of cool. So let's go into the player script. We already created the structure for this. First of all, we're going to make the player go upwards inside of the flap function. To do that, we can use the linear velocity variable of the rigid body 2D. And we're specifically interested in the y velocity, which is the vertical velocity. If this is positive, the player is going down. So down is positive and up is negative. So we can set this to be something negative to make the player go upwards. In this case, that number is going to be negative 340, which is a number I tested. This is going to work well. Now we should be able to run the game, and each time we flap, each time we press the left mouse button, the player is going to go upwards a little bit. Just like that, because we're setting the linear velocity to be negative. At the same time, we want the player to rotate counterclockwise, and we can do that with the angular velocity built-in variable here. In order to go counterclockwise, we need to set this to be something negative. Previously, we were setting it to be positive while we're falling down, so that the player rotates like that to face downwards. This time, we're going to rotate counterclockwise and face upwards like that. So right here, we'll set it to be something like -8, which is something I tested. This is going to be fine. Now you can see that each time I flap, the player rotates counterclockwise, but at the moment there's no limit, so we can do a full circle if we wanted to by flapping over and over again. We need to put a limit on that, and we can do that inside of the physics process, just like we did for the other rotation. First of all, we're going to check if the rotation degrees is less than or equal to -30, which is going to be our maximum that we want to rotate. If it is less than this, that means we have reached the maximum, and in fact, we're over the maximum. So we should go ahead and correct it by setting the rotation degrees to be -30. And then we're also going to set the angular velocity to be 0 as well to stop further rotation. Now we should be able to play. And when we flap, the player is going to stop at -30, as you can see. You can also see that we're correctly playing the flap animation as well, which is more apparent now that we can actually flap. Good, both of the rotation limits seem to be working just fine. So this is working, but we have all of these hard-coded numbers inside of our code, and when we first look at this, or someone else looks at this, it's not going to make sense. They're not going to know what's going on here. So this is not a good practice. Instead of having these numbers, we want to turn these into variables. For example, I can take this -340. Up here, I can create a variable called flap force, set it equal to -340, and use this instead of that hard-coded number. And this way, when someone looks at this, they understand that we're setting it to the flap force instead of just some random number. We can do the same for this angular velocity. We can call this the flap angular force, just like that. And we're also going to do it for some of these numbers as well. We can do it for -30, which will be our maximum rotation going upwards. We can do it for 90, which is the maximum rotation going downwards. And we can also do it for the angular velocity 5 here, which would be the falling angular velocity or falling angular force. We can leave the zeros as they are. We don't need to turn these into variables. And creating these variables will actually be your challenge. Go ahead and turn the hard-coded numbers that I showed you into variables. Don't worry too much about the naming of the variables. Just create a variable that makes sense to you. And later on, if you want to, you can use the names I'm going to come up with. Pause the video, give it a go, and come back when you're done. Alright, let's start with the -30 here. I'm going to call this the maximum rotation up, -30, and then we can use it here and here. Next up, we'll do 90, which is going to be the maximum rotation down, and then we'll use it here. And finally, we'll turn this 5 into falling angular velocity 5. This way, these numbers actually mean something, and when we look at the code, it is more obvious what we're trying to do. If we play the game, nothing is going to be different. The player is going to work exactly the same way, but the code is going to be better and improved. Cool, so this is essentially how the player is going to move inside of the game. Okay, so next up we are going to create the ground so that the player has something to fall into instead of just going outside of the screen. This is going to be a new scene. We're going to create a static body 2D for the root node, which is a physics body that can't be moved by external forces. So it's the perfect physics option to use when creating something like ground or something like a platform. We're going to name this to be ground and save it into the scenes folder. We're also going to create a script for this. And that will go into the scripts folder, of course. Inside of the scene, we're going to create a sprite 2D to display the texture, a collision shape 2D for the static body 2D. We'll also create an animation player because we're going to make the ground scroll. That will be an animation. For the sprite 2D, we're going to use this ground.png. We're going to go into the offset here and turn off the centered so that the top left of the sprite is at the origin or the center of the scene. This is just going to make it easier to position it. Let's also create a collision shape, which is going to be a rectangle that we're going to place onto the texture and resize to cover all of it, just like that. I'm going to leave just a single pixel here, and you will see why in just a second. Actually, we don't even need to do that. I'll just cover all of it. I'll explain why I did that in just a second, but first of all, let's place this into the game to see what it looks like. We're going to move it down, of course, and place it at the bottom of the game, just like that. Now when we play and fall down, there is something that we can actually fall into or fall onto. And we can kind of move forwards this way, which is kind of funny. But of course, in the end, this is not going to happen, because as soon as the player touches the ground, we want to stop the game and lose the game. We're going to implement that as well, but first of all, I want to create the animation that we're going to use for this. I'm going to hide the collision shape just for a second so that we can see the sprite better. At the moment, the sprite is a little bit too small in order to animate it. We want to make it wider. We can do that using the region settings on the sprite 2D. So turn this on. Next up, we need to set the width and the height of the sprite. If you take a look at the ground PNG, you will see that the width is 504 and height is 168. So for the height, we'll say 168, but the width is going to be larger, something like 800. And as you can see, that's going to make the sprite wider, but at the moment it is being stretched at the end. In order to fix that, we need to go into the texture settings and set the repeat here to be enabled. That way, we're going to be able to extend the sprite as much as we want using the width of this rectangle of the region settings. But like I said, 800 is going to be enough. What we want to do is very simple. We want to move this sprite to the left, and then we want to move it back to the right. That's going to create the illusion of scrolling. We're going to do this because, as you recall, the player is actually not going to move. It's going to stay in one place. Because of that, in order to create the illusion that we're actually moving forwards, we're going to create this scrolling animation for the ground. So we'll set the position of the sprite to 0, 0. Then we're going to create an animation that we're going to call scroll. This is going to be autoplay and loop. It's going to be 1 second long. Let's zoom in a little bit. What we want to do is very simple. At the start of the animation, we want to key the position of the sprite at 0, 0. Then at the end of the animation, we want to move the sprite 2D to the left and key that position. And since this is going to loop, it's going to move the sprite, then it's going to go back to the beginning and place it at 0, 0. So let's go ahead and create the first key at 0, 0 for the sprite 2D at the start of the animation. Then we'll go to the end of the animation, and we're going to move the sprite 2D to the left. The important part here is to match this pattern that is at the start of the sprite. You can see that this pattern is repeating across the sprite, and the final position we place this at needs to match this at the start here. So you can see that there's a pattern here going upwards, 1 pixel at a time, and at the start there's an empty space here, just 1 pixel. This needs to be the same after we move it, in order to create a smooth looping animation. So let's click on the sprite and let's start to move it to the left. We need to stop it at somewhere like this, so that the pattern here is the same, as you can see. But at the same time, we want to move it enough to make the animation fast. So we're going to continue to move this up until we get to somewhere around here, which is going to be -216. We don't want to move it too much that the entire sprite goes into the game area. That's not going to make it look seamless. But at the same time, we want to move it enough in order to create some speed for the animation. You can see that at the start here, the pattern is the same. There's a single spot missing at the start. So we can go ahead and key this position, just like that, to the end of the animation. Now we can play. Looking from this distance, it's not going to look good, but when we zoom in, it's going to create this smooth, seamless looping effect or scrolling effect, as you can see. Awesome. So we can stop that, go to the beginning, and now we should be able to play the game. And we're going to have this scrolling animation effect at the bottom. And now actually, it seems like we are moving forwards, but we're actually not. We're at the same spot. Cool, so next up, we want to detect when the player touches the ground. Because when the player touches the ground, we want to end the game. We're actually going to end the game in 2 different cases. If the player touches an obstacle, that's going to be the first case. And the next case is going to be the player touches the ground without touching an obstacle. In that case, we also want to finish the game. So we need to be able to detect the player. That's going to be done in the ground scene. And whenever we want to detect something in the game, we usually want to use an area 2D. Because the area 2D has the ability to detect when other physics bodies enters its collision shape. So in the ground here, we'll create an area 2D. We're going to call this the death zone. The area 2D also needs a collision shape. Let's turn back the collision shape of the static body 2D as well. And let's create a collision shape for the death zone, which is also going to be a rectangle. We don't need this to be the size of the texture. We can simply place this just above the collision shape of the static body 2D. Just like that. So that we can detect when the player touches it. That's all we need to do. It doesn't need to be tall, and we're not going to make it touch the static body 2D. We're going to leave a pixel of gap here. That's why initially I tried to make the static body 2D's collision shape a little bit smaller, but it's also going to work this way. In order to make it detect the player, we need to connect the body entered signal to the ground script, and that is going to be your challenge. Go ahead and connect the body entered signal of the death zone area 2D to the ground script. And after you do that inside of the callback function, I want you to print a message, something like player entered the death zone. Pause the video, give it a go, and come back when you're done. Alright, we are going to click on the death zone, go into the signal section here, double click on body entered, and then click on connect. That's going to connect that signal to the ground script. And this function that was created, this is called the callback function, will be called when a physics body enters the death zone. So in here, we're going to print a message, something like player entered the death zone. And now when we play and touch the death zone, that message should be printed. If you got this message twice, it is probably because the collision shape of the death zone is touching the static body 2D. So that is why we have that gap here. In order to make it work without the gap, we can go into the player script. At the top, we can create a class name called player so that we can refer to the player inside of our scripts. And then inside of the ground script, we can check if the body is the player and then print the message. That way, only when the player enters the death zone, that message is going to be printed, which is going to make our code a little bit safer. So if you don't know how the area 2D works, it's very simple. It has a collision shape and it has some signals that is going to give us information about what's going on with that collision shape. The body entered signal is going to be emitted when a physics body enters the collision shape of this area 2D. In this case, when the player enters the collision shape, when it falls onto it, this signal will be emitted. We connected a function to this signal in the ground script, which is right here, which means this function will be called when that signal is emitted, and the player is going to be given to us with this argument called body. So in this case, you can think of the player as this variable here called body, and we're also double checking that it is indeed the player, and after that we're printing this message. So that is essentially going to be the scrolling background that we're going to use in the game. Okay, next up we're going to start to work on the obstacle system. This is going to have two parts. First of all, we're going to create the obstacle scene. This is going to be the scene with the pipes. Then we're going to create the obstacle spawner scene, and this one is going to spawn these obstacles using a timer. Inside of the obstacle scene, we're going to have two area 2Ds for the pipes. So these will be area 2Ds. These are going to detect when the player touches them, and then they're going to essentially kill the player. The scene itself is going to be a character body 2D that we're going to move to the left. In the middle, we're going to have another area 2D in order to detect when the player goes through the pipes so that the player can score. That is the plan. Let's go ahead and create a new scene. At the root, like I said, we're going to have a character body 2D, which is a physics body that we can move using our script. Unlike the player, the obstacle doesn't really need to have any physics capabilities using the physics system. We simply want it to constantly move to the left, and to make something like that happen, character body 2D is a good option. We're going to name this to be obstacle, save it into the scenes folder. Let's also create a script for this inside of the scripts folder, just like that. Then we're going to create the nodes. First of all, the character body 2D needs a collision shape. We're not going to use this collision shape because the character body 2D itself is not going to collide with anything. We're simply going to use it to make it move. Because of that, we're going to create a basic rectangle and then click on disabled to turn it off. Next up, we're going to create the pipes. These are going to be area 2Ds. We'll start by creating the one on the top. We're going to rename this to pipe top. In here, we'll create a sprite 2D and then a collision shape. The sprite 2D is going to use the pipe.png texture. This one is going to be on the top, so we need to flip this vertically. We can do that from the offset section here by turning on the flip V option, just like that. Next up, we're going to create a collision shape for this, which is going to be a rectangle that we're going to resize to cover the entire texture, just like that. And for the top section, we're going to make this very, very tall so that the player cannot go above it, essentially, and try to cheat the game. So we're going to create something like that. Next up, we're going to move this up. I'm going to click on the pipe area 2D here and move it up by 300 pixels, just like that. That's the first one. Now we're going to create the second one, which is going to be at the bottom. And creating this one is going to be your challenge. Go ahead and create the pipe bottom area 2D with a sprite 2D and a collision shape and do its setup. This one is going to be 300 pixels below the origin, and it's going to use the same texture as pipe top. Pause the video, give it a go, and come back when you're done. Alright, let's create another area 2D. Rename it to pipe bottom. Let's create a sprite 2D and a collision shape as well. The sprite 2D is going to be the pipe. This time we don't need to flip it because it's going to be at the bottom. I'm going to move the entire area 2D downwards by 300 pixels on the Y. And then we can create the collision shape. This time we don't need to make it very tall because the player can't go through the bottom. There is the ground at the bottom. That's not going to be possible. So we can just cover it like that, which should be enough. We're going to create one more area 2D in the middle, which is going to be the score area. So let's rename that. This one doesn't need a sprite 2D. It's only going to have a collision shape, which is going to be a rectangle. Now we're going to resize to cover the entire gap here. And then I'm going to move this to the side a little bit so that the player scores when it reaches this point right here. Good, so that is the setup for the nodes. Next up, we're going to connect some signals to our script. First of all, we want to connect the body entered signal of the pipes so that we can detect the player and then kill the player. Since both of these are going to do the same thing, we're going to connect them both to the same function. First of all, we're going to create that function inside of the script. I'm going to call that on pipe body entered. We can take a look at the signal to learn the argument. you can see that the body entered signal is going to take in an argument called body, which is going to be of type node2D. Just like that. Then we're going to connect the body entered signal of these pipes. So let's start with pipe top, double click on the signal. We're not going to use the method that it's recommending here. We're going to pick the function that we created, just like that. We're going to do the same for pipe bottom as well. For body entered, let's pick that function. Now the same function is going to get called when a physics body enters either of these area 2Ds, the pipes. The physics body that enters is going to be passed to us as this argument. We can check if that's the player. And then we can print something like player touched a pipe. Next up, we're going to connect the body entered signal of the score area as well. So click on the score area, go to the signals, double click on body entered, and for this one we can use the function that it is recommending here. When the player enters the score area, we want to score. In this case, we'll simply do the same check for the body argument. Is it the player or not? If it is, we can print player scored. Just like that. Next up, we can go into the game scene and instance an obstacle. I'm going to place it behind the ground. That's what it's going to look like in the game. But obviously at the moment it's not moving, so we're not really going to be able to test it unless we place it directly above the player. That way you can see that the first callback function is working for the top. We can also test the bottom pipe. You can see that the same function is called, so those signals are working. And we can also test the score area just like that. And that also seems to be working. But of course, we don't want to test this like this. We want the obstacle to go to the left so that we can actually interact with it in a normal way. And to do that, we'll go into the obstacle script again. We're going to create the physics process function up here to make it move. The character body 2D has a function called move and slide that we can call. This is going to make it move based on the velocity variable. Velocity is going to control the speed and the direction of this character body 2D. It's a vector 2D, which means it has an X and Y property. X is going to control the horizontal velocity, Y is going to control the vertical. And on the X, if this is set to be negative, it's going to go to the left. If this is set to be positive, it's going to go to the right. So to make it go to the left, we're going to set this to a negative value. And in this case, that value is going to be negative 215, which is going to be a good speed that I tested beforehand. And I'm actually going to turn this into a variable up here called speed, which is going to make the code more readable, of course. And with this code, the obstacle should be moving to the left, as you can see. We can also try to touch the pipes. And everything seems to be working fine. The only problem we have with this is that after the obstacle goes outside of the game area, we need to delete it. Otherwise, we're going to have performance issues. We're going to have tons of obstacles that are not being used outside of the game area. To do this, we can simply check the horizontal position of the obstacle. Let's take a look at that. While it's inside of the game area, the X position, the horizontal position, is going to be positive. And as soon as it goes outside, it's going to become negative, as you can see. So we can come up with an arbitrary threshold, something like negative 200. And if it is below negative 200 on the X, we can delete it. To do that, we can use a simple if statement inside of the obstacle script. After we make it move, we can take a look at the position with the global position variable. This is a vector 2. And we can use the X property to take a look at the horizontal position. If this is less than negative 200, which is the threshold that we're going to use, we can call the queue free function to delete this obstacle scene. We can also print a message here and say obstacle out of game area, deleting it. Now we should be able to play the game, and after the obstacle goes outside, it is going to get deleted, as you can see from this message here. We can also take a look at the remote tab. You can see that the obstacle is here, and now it's deleted. Great, we don't need to keep that message there. The point has been made, and this is going to be the beginnings of the obstacle scene. Alright, now that we created the obstacle scene, let's also create the obstacle spawner scene. This scene is going to have a node 2D at the root that we're going to place right outside of the game area. From this point, we're going to start instancing obstacle scenes. And to do that, or to control that, we're going to use a timer. Each time the timer times out, a new obstacle will be instanced. We're also going to randomize the Y position of each obstacle so that each one has their gap at a different location to create the variety in the game. Alright, let's go ahead and create this scene, which is going to have a node 2D at the root that we're going to rename to obstacle spawner. Save it into the scenes folder, and we're also going to create a script for this and save that into the scripts folder. Next up, we're going to create the timer node, and we're going to rename this to spawn timer. The wait time is going to control how often we spawn an obstacle. We're going to set this to 1.5, which is going to mean a new obstacle will be instanced every 1.5 seconds. But you can change this in order to change the difficulty of the game. This timer is not going to be auto start because we don't want to start spawning immediately when we play the game. We only want to start this after the player does the first flap. That is how the game is going to work. And because of that, auto start is not going to be ticked. Instead of that, inside of the script, we're going to create a start and a stop function in order to control this. First of all, let's implement start. We also need to create a reference for the spawn timer. We can left click hold, drag it into the script, hold down the control key, and release the left mouse button. That is going to create a reference. Then we can use it inside of this function and call the start function. This is going to start the timer. We're also going to create a stop function in order to stop the timer, and I'm going to give that one to you as a challenge. Go ahead and write the stop function that is going to stop the spawn timer. Pause the video, give it a go, and come back when you're done. Alright, we're going to call this stop. It's going to use the reference spawn timer, and it's going to call the stop function just like that. The stop function is going to be called when the player dies, and the start function is going to be called when the player first flaps its wings at the start of the game. Let's also connect the timeout signal of the spawn timer to this script. Now that we connected it, this function will be called each time the timer times out, and in here we can print a message, something like spawn obstacle. And I'm going to put this at the top. In this function, we're going to spawn a new obstacle, but before we do that, we're going to implement calling the start function at the start of the game. So let's think about how we can do that. Inside of the player script, we have a start game function. When we call this function, we're going to emit a signal. That signal will be emitted. We're going to connect it to the game here. So we're going to have to create a script for the game as well. And inside of that callback function in the game, we're going to start the obstacle spawner. Alright, so first of all, I'll create a script for the game in the scripts folder. Then I'm going to delete this obstacle instance from here. And instead of that, I'm going to instance an obstacle spawner. I'm going to place this behind the ground, and I'm also going to put the player in front of everything. I'm also going to place the obstacle spawner to the right side of the game area at 700 on the X, and 400 on the Y. Make sure to use the same numbers because my calculations for the spawning will be based on these numbers. Next up, we'll go into the player script. At the top, we're going to create a signal called game started. And we're going to emit this signal in the start game function. Just like that. Then we'll go into the game scene, click on the player, go to the signals. Here is the signal that we just created. We're going to double click on this and connect it to the game script. Now this function is going to get called when the player calls the start game function. We can confirm that by printing something here. So when I click, that function should be called and the game started should be printed, as you can see. Now in here, we're going to start the obstacle spawner. So first of all, we'll create a reference for that in the script. Then we'll use that reference and call the start function that we implemented just a second ago. Now when we play the game and flap our wings for the first time, the start function of the obstacle spawner will be called and then the timer is going to start working. As you can see, now that the timer has started, it's going to wait for 1.5 seconds, it's going to time out, this function will be called and it's going to start again and continue that loop. Now all we have to do is to actually spawn an obstacle in here. To do that, first of all, we need to load the obstacle scene file or the resource into this script. We're going to create a variable for that, which is going to be the obstacle scene. The type is going to be a packed scene. And we're going to use the preload function to do this. This is going to take in the file location of the obstacle scene as a string. To get that, we can drag the obstacle scene from the file system into this function just like that. This is going to load the scene into this variable. Then we're going to use that variable and call the instantiate function in order to create a new instance of the obstacle scene. And then we'll save that in a variable called obstacle. Just like that. Next up, we need to call addChild and pass the obstacle instance that we just created in order to actually add it into the game. And this is going to add it as a child of the obstacle spawner inside of the game here. Now we should be able to play the game. Start the game. And obstacles are going to be spawned each time the timer times out, as you can see. Perfect. So that is working just fine. But obviously, all of these obstacles are at the same position vertically. We need to randomize that. What we can do is, inside of the spawner, right after we create the obstacle, we can change the position.y, which is the vertical position. And this position is relative to the parent. If you use the global position, that's not relative to the parent, but if you use the position variable, it is relative to the parent. We're going to get a random number by calling the randomf_range function. And in order to determine the range, let's do an experiment inside of the game. I'm going to instance an obstacle as a child of the obstacle spawner. We're going to take a look at its position. At the moment, it is at 0, 0, as you can see. This position of the obstacle is relative to the spawner. That's why it is 0. Let's try to move it down and see what is a reasonable maximum position. I don't want to place it too much close to the ground like that. I feel like something like 120 is going to be good for the maximum position it can reach towards the bottom. And in terms of the opposite direction, let's see. I feel like something like that is going to be good. We don't want it to be any higher because that's going to be too difficult to reach. So it seems like -250 is going to be good for that. And the other one was, I believe, 120 positive. All right, we can get rid of this, delete it. And then in the code, we can set this to be -250 to 120. And this function is going to give us a random number between these two limits. And we're going to use that random number to set the position. Now we should be able to play the game. Each time an obstacle scene is instanced, it's going to receive a random Y position, as you can see. And if you want, you can play with these numbers. You could also turn these into variables. Something like maximum Y position. And let's set that to be -250. And then the minimum Y position. And that's going to be 120. The maximum is negative because in Godot, going up is negative on the Y. Now we can use these instead of the hard-coded numbers, and this is going to make more sense. Alright, now everything should be the same, but we have those nice variables. And essentially, the obstacle spawner is complete. So next up, we are going to implement player's death. Let me explain how this is going to work. First of all, inside of the player script, we're going to create a Boolean variable called isAlive. This variable is going to control whether or not we can flap. We're also going to create a function called die, and this function is going to set isAlive to false. We're going to call this die function if the player falls on the ground or if the player hits an obstacle. Let's start by creating the Boolean and the function inside of the player script. At the top, we're going to create isAlive, which is going to be true by default. Then at the bottom, we're going to create the die function, which is going to look like that. In here, first of all, we're going to check if isAlive is true, because we only want to run the die logic if we are currently alive. If isAlive is set to false, we don't want to do this again. And in here, we'll set isAlive to false. Next up, inside a physics process where we do the input, we're also going to check if the isAlive boolean is true. We can do that using the AND operator, just like that. Now this if statement is only going to be true if the input is pressed and isAlive is true. So that is going to be the die function and the isAlive boolean. Now we need to call the die function when the player touches the ground or when the player hits an obstacle. Let's do the obstacle first. Inside of the obstacle scene, we have the pipe top and pipe bottom area 2Ds, and previously we connected their body entered signal to this function. At the moment, we're simply printing a message. Now, instead of printing a message, we need to take the body, which is the player, and call the die function, just like that. Now we should be able to play the game. And when we hit an obstacle, the die function will be called, and we're not going to be able to flap anymore because isAlive is going to be false, as you can see. Good, so that is the first case. And next up, we also want to do that when the player touches the ground. And that one is going to be your challenge. Go ahead and call the player's die function when the player enters the dead zone area 2D inside of the ground. Pause the video, give it a go, and come back when you're done. Alright, this is going to be extremely similar. Inside of the ground scene, we have the dead zone, of course, which is an area 2D we created, and we previously connected its body entered signal to a function in the script. Now all we have to do is to use the body argument, which is the player, to call the die function, just like that. And now we should be able to hit the ground, and then we're not going to be able to flap anymore because the die function inside of the player script is going to get called. So this is great, but as you can see, after we die, the ground continues to scroll. We continue to spawn more obstacles, and the obstacles are also moving. So we need to take care of those three problems. The best place to do that is going to be the game script. So what we need to do is we need to emit a signal from the player when it dies. We need to connect it to the game script. And in that callback function, we need to stop the ground from scrolling. We need to stop the obstacle spawner from spawning more obstacles. And we also need to stop the obstacles in the game from moving. So let's go into the player and create that signal at the top, which is going to be the died signal. We're going to emit this in the die function, just like that. Then we'll go into the game scene, click on the player, go to the signals. Here is the died signal. Double click on it and connect it to the game script. This should be called when the player dies. We can test that real quick with a message. Now when I hit the ground, it should be called. And also, if I go ahead and hit an obstacle, it should be called just like that. Perfect. Now in here, we can do those things. The easiest one is going to be calling the obstacle spawner's stop function, which should stop the spawning after we cease to exist. Let's see. And as you can see, after I hit an obstacle, we are not spawning anymore, which is perfect. Next up, we're going to stop the ground from scrolling. And to do that, we can simply pause the animation that is playing. To access the animation player from the game script, we're going to create a reference for it in the ground script. So we'll do that real quick. And then we can go into the game script. We'll create a reference for the ground in here. And then we can access the animation player, the reference that we just created, and call pause, which is going to pause the animation that is currently playing. Now we should be able to play the game, hit the ground, and the animation is going to pause, as you can see. The final one is going to be stopping the obstacles that are currently in the game area after the player dies. To do that, first of all, we'll go into the obstacle script. In here, we can set the speed to be 0 to stop an obstacle. And we're going to create a function that does just that. This will be called stop. And it's going to set the speed to be 0. We need to call the stop function of every obstacle that is in the game area. And to implement that, we're going to create a group. Inside of the obstacle scene, click on the root node and go into the group section at the top right. In here, we're going to create a new group called obstacles. Then we can go into the game script. We can get the scene tree by calling get tree. There's a function here called call group. And this function is going to call a function on every scene that belongs to a certain group. The first argument is going to be the group name, which is obstacles. And the second argument is going to be the name of the function that we want to call. And that's going to be the stop function that we just created. Both of these need to be strings, as you can see. Now when the player dies, we're going to call the stop function of all the scenes that belong to the obstacles group. Let's see if this works or not. Just gonna wait for some obstacles to spawn in. Then we can touch one. And as you can see, all of them just stop. And that is essentially the death mechanic of the player. Now we can either touch the ground or touch an obstacle. And in both of those cases, the player is not going to be able to flap anymore. And everything is going to stop in the game to indicate that we stopped. Or we just got killed, essentially. Okay, so now that we have the player and the obstacles implemented, let's go ahead and start to work on the scoring system. Inside of the obstacles scene, we have the score area, which is an area 2D. When the player enters this area, we're going to score. In order to keep track of this, we're going to create a variable inside of the game script. This is going to be an integer, and at the start of the game, it is going to be 0. When the player enters the score area of an obstacle, we're going to emit a signal. We're going to connect it to the game script, and using that signal, we're going to increase the score variable each time we go through an obstacle. That is the basic idea, and later on we're also going to create a high score system, but first of all we're going to implement this basic logic. So let's start by going into the game script. Up here we're going to create that score variable, which is going to be 0 at the start. Then we're going to go into the player script. At the bottom we're going to create the score point function, we only want to score a point if we are alive. So first of all, we'll check if is alive is true. If it is true, we're going to emit a signal. Creating that signal is going to be your challenge. Go ahead and create a signal called scored inside of the player script. And after that, I want you to emit the signal when the player scores a point, which is going to be inside of that function we just created. Pause the video, give it a go, and come back when you're done. All right, at the top, we'll create this signal, scored, and then we'll emit it right here. Next up, we'll go into the game. We'll click on the player. Here is that signal. We'll connect it to the script, the game script, just like that. And now this function should be called each time the player calls the score point function, which is going to happen when the player enters the score area of an obstacle. So let's implement that. Let's go into the obstacle scene. Here we have the score area, and we already connected the body entered signal of the score area to this script right here. At the moment, we're simply printing a message, but now we're going to use the body argument, which is the player in this case, to call the score point function, just like that. Now, each time we enter a score area, we're going to call the score point function inside of the player script. Then we're going to emit the scored signal, which is in turn going to call this function inside of the game script. So just to see this working, we can print a message here. Player scored a point. And now we should be able to play the game. Go through an obstacle, if I can, and that function is going to be called, as you can see. And in here, inside of this function, all we have to do is to take the score variable, increase it by 1, and then we can print it to take a look at it as well. Let's go ahead and play the game. We should be able to go through an obstacle, and as you can see, the score variable is being increased by 1 each time, and after that we are printing it. Perfect. With this, we are keeping track of the score inside of the game script using the score variable, which is going to be the foundation of our score system. Alright, next up we're going to display the score on the screen. To do this, we're going to use a label node that we're going to place here, and this is going to display the current score of the player. We're going to create this inside of a scene that we're going to call the HUD, which is going to house all of the user interface elements that we're going to create for the game. So let's start by creating that HUD scene. This is going to have a canvas layer at the root, which is going to let us render the user interface elements at a different layer from the game. We're going to call this the HUD, which stands for heads up display. We'll save it into the scenes folder, and we're also going to create a script inside of the scripts folder, just like that. Let's go ahead and create a label node here, which is going to be the score label. We're going to give this some placeholder value like 999. And later on, we're going to set this to be the current score of the game inside of our script. Let's create some label settings to customize this. Inside of here, we're going to set the font to be the font that we have in the assets, the Flappy font.ttf. We're also going to increase the size to be 48. Then I'm going to set the anchor settings to be top wide, just like that. And then we're going to set the horizontal alignment to be center and also the vertical alignment to be center as well. We're also going to create an outline for this in the label settings. The color of the outline is going to be black. So we'll turn off the value to be 0 to do that. And then we're going to give this outline a size, which is going to be something like 16, which I think is going to look good. Great, so that is what the label is going to look like. We can go into the game scene, instance it. I'm going to place it at the top, and we can play the game just to see what it's going to look like. I think it is looking just fine. we need to set the text of this label to the score of the game at the start and also each time the player scores. To do that, inside of the HUD script, we're going to create a function. But before we do that, we actually need to create a reference to the label in here. Then we'll create the function called setScore, which is going to accept an argument called newScore, which is going to be an integer. Then we're going to take the score label. We're going to access the text property, which is the property that we set right here in the inspector. We're going to set this to the newScore, but we need to turn newScore into a string using the str function first. With this function, we can update the score label to a new score that we're going to pass. And this is going to happen inside of the game script. Right here, we'll create a reference to the HUD first of all. Then we're going to create the ready function, which is going to be called at the start of the game. And in here, we're going to say HUD.setScore, and we're going to pass the score variable, which is going to be 0 at the start of the game, which means when we first play the game at the start, the label is going to say 0, as you can see. Next up, we want to update this label again each time the player scores, which, as you know, is going to happen inside of this function right here, and I'm going to give this to you as a challenge. So go ahead and update the score label to the new score when the player scores a point. Pause the video, give it a go, and come back when you're done. Alright, all we have to do is to call the same function right here instead of printing the score. This way, when we play the game, and each time we go through an obstacle, the label is going to be updated, as you can see. Perfect. So that is going to be how we display the score on the screen using a label from the HUD scene. And later on, we're going to create more user interface elements in here as well. Okay, so next up, we're going to display a message at the start of the game. If you take a look at the textures folder, there's an image called message.png, which looks like this. We're going to display this image at the start of the game, and we're going to hide it once the player starts playing. We're going to do this inside of the HUD. In order to display this image, we're going to create a texture rect node, which is going to display a texture as a user interface node. We're going to assign message.png as the texture property, and then we're going to center it using the anchor preset center. Then I'm going to move it slightly upwards, about that much, so about 120 on the Y, because I want it to be at the same height as the player, but it seems like at the moment the player is a little bit higher than I thought, so I'm actually going to pull it down just a little bit. Great, so now when we play the game, we should be displaying the message, and this bird in the message should be at the same length, or same height rather, as the player. Good. Next up, we want to hide this after we start playing the game. To do that, we can simply turn off its visibility, but I want to do something that is a little bit more fancier. I want to animate its alpha. So if we go into the HUD, click on the texture rect, we should also rename this. I'm going to rename it to start message. If you go into its visibility settings, there's a property here called modulate. If you click on this, you'll get a color picker, and this has an alpha property. You can use this property to control the transparency of this texture rect. I'm going to animate this down to 0 in order to hide it. So at the start, it's going to be full, then it's going to go to 0. And to do this, I'm going to use a tween, and I'm going to do it inside of the script. First of all, we're going to create a reference to the start message. Then we're going to create a function called hide start message, which is going to look like this. In here, first of all, we need to create a tween. To do that, we need to get the scene tree by calling getTree. And the scene tree has a function called createTween, which is going to create a tween object and it's going to return it. And we'll save it in a variable that we're going to call tween. And this has the data type of tween. Tween is a very useful class that is going to let us animate a property of an object. If you want to, you can control click on it here in the script, which is going to take you to the documentation page and you can read more about it. In order to animate a property, we're going to use the tween's tween property function, which is going to take the object that we want to animate. That's going to be the start message, texture rect. Then it's going to take the property that we want to animate as a string. The property is the modulate, and we want to animate the alpha of the modulate. And to get the alpha, we're going to use a colon and say A, because that is how the alpha is represented inside of the modulate in code. Then we're going to give this the final value we want to animate towards, which is going to be 0. At the end of the animation, we want the alpha of the modulate to be 0. And finally, it's going to take the duration of this animation, and let's say something like 0.5 seconds. This is enough to create this animation, and tween property function is automatically going to start the animation as well. Now we need to call this function when the player starts the game, and I'm going to give that to you as a challenge. Go ahead and call hide start message when the game begins. Pause the video, give it a go, and come back when you're done. Alright, we're going to do this inside of the game script. Right here we have a function called onPlayerGameStarted. We know that this function will be called at the start of the game. So in here we're going to access the HUD, and we're going to call the hide start message function that we just created. Now we should be able to play the game. And when we begin, the start message is going to be animated away as you just saw. Perfect. So that is going to be the start message that we're going to display at the start. And that is also the animation that we're going to use in order to hide it. Okay, so next up we're going to create the game over screen, which is going to be a user interface scene that we're going to display right after the player loses the game. On this screen, we're going to display the score, the high score, and also a button to replay the game. This is going to be a new scene that we're going to create, and then we're going to place this scene inside of the HUD before we use it. So let's go ahead and create the scene. It's going to have a control node at the root that we're going to call game over screen. We're going to save it into the scenes folder and create a script here as well. Just like that. Inside of here, we're going to, first of all, create a panel node, which is going to be the background of the menu or the screen. We're going to center this from the anchor settings right here. And then we're going to make it larger, something like that. Inside of here, first of all, we're going to create a texture rect that is going to display a game over message. Then we're going to have the score, the high score, and the button. That texture is inside of our textures folder right here, as you can see. So let's go ahead and create a texture rect. Everything that we're going to create is going to be a child of this panel. We're going to call this the game over texture rect. We're going to assign it the game over PNG, just like that. Then we're going to use the center top anchor preset, just like that, and move it down slightly, something like that. Next up, we're going to create the score label, which is going to be another child of the panel. Rename it, and then we'll give it some placeholder text like score equals 999. We're going to create some label settings for this. Open that up. In here, we're going to set the font, make it larger, something like 48. We're also going to create an outline, which is going to be size 16, and it's going to be black. Just like that. I'm also going to center this horizontally and vertically as well. Then we'll go into the anchor settings and place this at the center, just like that, and move it up slightly. That is going to display the score. Now we're going to duplicate this by hitting Ctrl D while we have it selected. We're going to move it down and change the text to say best instead of score. This is going to display the high score. We're also going to change the node name to be high score label, just like that. And finally, in here, we're going to create a button, which is going to be the retry button. The text is going to say retry as well. We'll go down into theme overrides so that we can change the font to the font that we're using. We can also change the size of the font to be 48. We're also going to go into constants and set the outline size to be 16 to give it an outline. Next up, we're going to center it, move it down, and I'm also going to resize it just a little bit to make it look nice. All right, I think this is looking good. Maybe we can make the panel a little bit shorter or smaller. Then we're gonna have to reposition these as well, just a little bit. All right, I think that is looking nice. Maybe move these a little bit more downwards, just like that. All right. Next up, let's go into the HUD and let's instance this game over screen to take a look at the position. And I think that's going to be just fine. Inside of the game over screens script, we're going to create two functions. But first of all, we're going to create references for the score label and the high score label. When we show this screen, we want to set these labels to the correct values. To do that, we need to create a function, and that function is going to be init screen. It's going to take in the score as an integer and the high score as an integer. Then we're going to access these labels, get the text property, and for the score, we're going to set it equal to score equals. Then we're going to append the score that we received. So we'll say plus string score. That is going to basically write score colon, and then it's going to turn whatever we received into a string, and then it's going to append it to the final text. Then we're going to do the same thing this time for the high score label. We can simply copy and paste that, change the label to high score label. The text is going to say best, and then the argument here is going to be high score. Now this function is going to essentially set up the game over screen before we show it. Then we're going to implement the functionality of the retry button. If you take a look at the signals of the button, there is a signal called pressed. This will be emitted when we press the button. Let's connect it to our script. In here, let's print a message to see if it is working or not. I'm going to run the scene, click the button, and as you can see, each time we click the button, this function is called. When we press the retry button, we want to reload the entire scene so that we can play again. We can do that with the scene tree. So we'll call getTree, and the scene tree has a function called reload current scene, which is going to reload the current scene that is running. In our case, that is going to be the game scene, of course. And with that, the game over script is going to be complete. At the start of the game, inside of the HUD, we want the game over screen to be invisible. So we're going to turn off the visibility, or we can just go into the modulate property from the inspector and set the alpha to be 0. We can also do that. I'm going to do both. After the player dies, we're going to show the game over screen. And in order to do that, we're going to create a similar animation that we did for the start message. We'll create a function here called show game over screen. This needs to receive the score and the high score. We're going to create a reference for the game over screen here as well. Inside of this function, before we show the game over screen, we're going to initialize it. So we'll call game over screen, init screen, and then pass the score and the high score that we received so that we display the correct values inside of the labels. Then we're going to make it visible. So we'll say game over screen, visible, which is a property that we use to control the visibility. This is a Boolean, and we're going to set it to be true. We're also going to set the alpha of the modulate to be 0, just in case, even though we did it from the inspector. So we'll access the modulate property. The alpha is called A, and we're going to set this to be 0, which is going to be completely transparent. So it's going to start as transparent, and we're going to animate it up to be fully visible, essentially. To do that, we're going to use a tween. So we're going to create one just like we did up here, and then we're going to call the tween property function. The object that we want to animate is the game over screen. The property is modulates alpha. The final value is going to be 1, which is fully visible. And the duration we can say is 0.5. That's fine. So this time we are doing the opposite. We're setting the alpha to be 0, and then we're animating it up to be 1, which is fully visible. In the case of the start message, we started at fully visible, which is 1, and then we animated down to 0. And finally, I'm going to create the ready function here as well, which will be called at the start of the game. And I'm just going to make sure that the start message at the start is visible by setting its visible property to be true. And then I'm going to set the game over screens visible to be false at the start of the game, just in case we mess with the values right here in the scene. This way we're still going to get the result that we're looking for. Awesome, now we have a screen that we can display that is going to show the score, the high score, and also a button to replay. We have the functions in place, or the function in place to initialize this screen, and we also implemented the button. And also inside of the HUD, we're correctly going to display the screen using this function. So that is going to be the final piece of the puzzle. Now we need to show the game over screen at the correct place, and that is going to be your challenge. Go ahead and show the game over screen when the player dies. As a small hint, you're going to do it inside of the game script. Pause the video, give this a go, and come back when you're done. Alright, we'll go into the game scene where we have the HUD. We know that the onPlayerDied function is going to be called when the player dies, which means inside of here we're going to call HUD show game over screen. We need to pass the score and the high score to this. The score is obviously going to be the score variable, and for now we can set the high score to be something random like 1, 2, 3, something like that, and we'll fix that later when we implement high score. Now when we play and die, we should display the game over screen, just like that. As you can see, the score is 0, which is correct, and the high score is the 1, 2, 3 number that we picked. And we can also retry with the button. That also seems to be working. Let's try to get a score, then die. And as you can see, that is also correctly displayed. One thing I want to improve here is that the game over screen is instantly shown after we die. I want there to be a very slight delay. To do that, we can use the await keyword, create a timer using the getTreeCreateTimer function. The timer is going to be for 0.5 seconds, and then we're going to wait for its timeout signal to be emitted. So this line is going to create a timer, and the await keyword right here is going to wait until the timer times out, and then it's going to continue with the function and show the game over screen, which is going to look like this. As you can see now, there's a slight delay before we show the screen, which I think is going to look nicer. And you can play with this number right here to customize that delay. And that is going to be the game over screen. Let's go ahead and implement the high score system, which is going to be done inside of the game script. Right here we have the score variable. Now we're going to create the high score variable. And we're going to set this to be 0 as well. This variable is going to be saved and read from the file system. When we die, if there's a new high score, we're going to save that into a save file inside of our system. And then at the start of the game, we're going to read from that file the previous high score, and we're going to save it into this variable. To make this work, first of all, we need to come up with a location for this file, the save file. That is going to be a string that we're going to call save file path. For this string, we're going to use the user location. The user location is a location inside of your file system, inside of the operating system, that Godot is going to pick. And this is going to be different based on the operating system that you're using. On Windows, it's going to be different. On Mac, it's going to be different. On Linux, it's going to be different. And on mobile, it's also going to be different. Which is very useful because using a single file location, we can handle all of these operating systems. Without this, we would have to create a different file path string for each system. So this really is going to make things easy for us. Inside of this location, we're going to create a save file. I'm going to call this savegame.dat, which is going to stand for data. This file extension is something I came up with. It doesn't really matter as long as it makes sense. Next up, we're going to create two functions in order to save and load the high score. The first one is going to be save high score, just like that. And then we're going to have load high score. In order to work with the file system, we're going to use the file access class. This class has a function called open, which is going to let us open a file from the file system. The path is going to be the save file path. And then we're going to tell it if we want to read or write to this file. We can do that with the file accesses, read or write values. In this case, we want to save it, so we're going to use write. This function is going to open this file if it exists. If it doesn't exist, it's going to create it. Then it's going to return it to us. And we're going to save it in a local variable like that. Now that we have it, we can use it. And the file has a function that we can call that is called store variable. This function is going to store a value inside of this file. And we're going to store the high score. And after that, we're going to call the close function to close the file. So this function is going to open up the file, store the high score into the file, and then close it. Then in load high score, we're going to open this file, this time to read it, and we're going to retrieve that value we stored earlier. Before we try to do that though, we want to make sure that the file exists. We can do that using the file accesses, file exists function. We're going to provide the save file path, and this is going to return true or false based on this file. If it exists, it's going to return true. Because if it doesn't exist, we shouldn't really try to load from it. It's not going to work. If it does exist, we're going to open up the file very similarly to what we did up there, but this time we're going to use read. Then we can use the get variable function in order to retrieve that variable that we stored up here. We're going to save this into the high score variable just like that, and then we're going to close the file. Let's go ahead and use these functions. At the start of the game, we want to load the high score that we have in the file system, in the save file. We can do that in the ready function by calling load high score. And then we want to save the high score if there is one after the player dies. After that play session is over, we want to check if there's a new high score or not. If there is one, we want to go ahead and save it. That is going to be an if statement. That is going to check if there's a high score, and writing that is going to be your challenge. Go ahead and write the if statement that is going to check if there's a new high score. As a small hint, There's a new high score if the current score is greater than the old high score. The old high score is going to be the one we loaded in ready into the high score variable, and the current score is going to be the score variable. Pause the video, give it a go, and come back when you're done. Alright, we're simply going to check if the current score that we got in the game is greater than the high score that we loaded in ready. If that is the case, if this is true, there's a new high score, so we should set the high score variable to the current score, and then we should go ahead and save that by calling the save high score function. And after that, we're going to pass the high score to the game over screen. Don't forget to do this. And that is going to complete the high score functionality. Now, when we play the game at the start, we're going to load in the high score if there is one, and then we're going to play the game. Let me get a high score of 2 and then die. You can see that we passed it correctly to the game over screen, and also we saved it now into the save file because this was a high score. And now next time I play, let's just get a single point and then die. As you can see, the high score is still here. It's 2. I can even close the game and play again, and the high score is still going to be there because now we're reading this, we're loading it from the save file. I can also go ahead and beat this by scoring something, more than 2, if I can actually play it. 1, 2, and 3. And now that is going to become the high score, as you can see, which should be always there, read from the file system. Awesome. So that is going to be the high score system of the game. Alright, now it is time to play some sound effects. We're going to do this inside of the player scene, and we're going to use the audio stream player node. We're going to use this basic version, not the 2D version. This first sound is going to be for flapping wings, so we're going to call this flap sound. And for the sound file, we're going to use the wing.wave file right here. So we'll just drag this into the stream property, and then we can hit this playing checkbox right here to hear what it sounds like. Next up, we'll go into the script. At the top, we're going to create a reference for this. And then inside of the flap function, we're going to use that reference and then call the play function. This way, each time we call flap, that sound is going to be played. Awesome. That is the first sound that we're going to play. And next up, we're going to create 2 more sound effects inside of the player. One for hitting something, which we're going to call hit sound. And one for scoring a point, which we're going to call score sound. The hit sound is going to use hit.wave, so we'll assign that, which is going to sound like this. And the score sound is going to use the points.wave, which is going to sound like this. Next up, we'll go into the script. We'll create references for these. And then we're going to play them at the correct places. And that is going to be your challenge. Go ahead and play the hit and the score sounds at the correct places inside of our script. Pause the video, give it a go, and come back when you're done. Alright, first of all, we'll play the hit sound, which is going to be played inside of the die function, of course. So we'll say hit sound.play. And with this, we should be able to hear it when we hit the ground, just like that, or when we hit an obstacle. Great. And finally, we're going to play the score sound here in score point. Just like that. Let's also test that. Which also seems to be working just fine. And those are going to be all the sound effects that I'm going to add into the game. If you take a look at the audio folder, we have some extra sound effects. If you want, you can try to use these as well, but for my game, I'm simply going to use these 3. And that's going to be the sound effects for the game. Okay, so the game is basically complete, and now we're going to learn how to export it so that we can share it with other people. First of all, we want to make sure that we have the export templates installed. We need to go into the editor menu, into manage export templates. In here, you're going to click on download if you don't have them installed. At the moment, I have them installed, so I don't have to do that. But if you don't have it, just click on download and wait for it to finish. Next up, we'll go into project, export. And in here, we need to create a preset for our operating system. In this case, I'm going to create one for Windows. Next up, we're going to select a path to export this. I'm going to create a folder here, actually outside of here, called export. You can create this anywhere you want. And then we're going to give this file a name, which is going to be flappy_bird.exe. This is going to be the executable file. Then we'll click on save. I'm also going to turn on embed PCK. PCK is a file Godot is going to generate with some data in it. If you embed it, it's going to be inside of the executable, which is going to make it easier to share your game. With this, we can click on export project. This is going to be the file location that we just selected with the file name that we just selected. I'm going to turn off export with debug. You should also do this if you're planning to send this to other people. If you're just testing it, you can leave this on. And then we're going to click on save. That is going to export the project and create an executable. Let's take a look at that real quick. Here is the folder that I selected, and here is the executable that was created. This is the entire game. There's nothing else, which makes it very easy to share this as well. All you need to do is to send this executable or upload it to somewhere and other people can play it. Let's double click on it. And just like that, we're going to be able to play the game that we created. Perfect. That is how to export and share your game.